last speaker in this session will be Ian Firth, coming from England. Ian Firth also has an international reputation as leading bridge designer and a strong advocate of elegance in bridges and the built environment. He has over 45 years of experience in design, assessment, and structural investigation of a wide variety of structures. In our communication, Ian Firth, and I like this, placed his projects in two categories. The most significant would be strengthening refurbishment of the Severn Bridge and the Westgate Bridge in Australia, or the conceptual design of Stonecutters Bridge in Hong Kong and the Messina Bridge project we've talked about today already. And the second category is the one I like most: enjoyable. Small footbridge projects such as the Sail Bridge in Swansea, Taplow Bridge across the Thames, and Bridge of Aspiration in Covent Garden. Ian Firth also mentioned his hobbies: music, he says mostly singing, theater, and the natural world. And recently he has taken up pottery. We're looking forward to your talk, Bridges New and Old, Low Carbon Solutions to Save the Planet.
Thank you very much for the introduction. This slide has been seen a number of times. Unfortunately, it's been squished or stretched, so it's not what it actually looks like, but you'll see the real thing in a minute. This is the Sail Bridge in Swansea. Are we getting there? That's the wrong one. I must admit, it's nice to get to a stage at the end of one's, or towards the end of one's career, to do something new. I've never spoken at a jazz location, Jazz Institute before, so thanks for that. And thank you, Mike, for the introduction, and all of you who've organised it. There we go, and thank you for being here. I don't know how I'm going to get through all these slides in 20 minutes, and so I'm not sure what time it is. I'm going to need to go very quickly because I've got too many. But I tried to kind of capture some of the things that have been special. There we go, that's what it should look like. It's actually a dismissible offence in my office. If somebody takes an image of a bridge, which we've designed carefully to get the right proportions, and then they stretch the image to fit the screen, you're dismissed. It's because I care passionately about how things appear. So a brief introduction. I'm going to take you back 25 years ago, because in the UK we had a whole raft of bridges, which is what I call the Millennium Bubble. Millennium bridges built to mark the turning of the millennium. I imagine that happened here and almost everywhere as well. The low carbon issue is one we've heard about a lot already, and I'm just going to focus on it a little bit. And there was a footbridge competition which we ran. I helped the National Highways to run last year. This year, actually, finishing this year. Just a little word about keeping old alive, because it's super important that we do. Looking after existing structures is absolutely essential, especially when you think about carbon. But it just, as a basic principle, we've got to do that. And then just a tiny word about regenerative design. So you know something about me. I've been at Flint & Neil for most of my career, which then became part of Corby. And then more recently, I'm working for myself. And it's mostly bridges, but not exclusively. And these are some of the things that I've been doing. I'm not sure which microphone I should be using. This one, I guess. So footbridges, road bridges and other things, railway bridges, and some big ones. And so you've already heard about some of these. I worked on Messina for 30 years or so, initially when with Flint & Neil advising the client, and then once the contract was awarded to Imprezilo, as they used to be called, now we build. Cowie was working for them as a designer, so when Flint & Neil joined Cowie, I had to change sides. I could no longer obviously work for the client, but I then went on to help with the detail design. And the thing on the right, the bottom right, was a study I did for Boris Johnson. You remember him? Who had this mad idea of building a bridge across the Irish Sea between Scotland and Northern Ireland. And he wanted to know whether it was possible and how much it would cost. Well, the answer is it is, and lots. But one other thing that I'm sort of passionate about, really, and some of you have heard me speak before, you all know about Vitruvius. You don't need me to tell you about what he stood for: utilitas, fermitas, and venustas in all structures. Function, strength and stability, elegance and delight. But unfortunately, in most engineering classes, most engineering schools, the question about elegance and delight is just not even touched on. And I care passionately about this because what we build has to be attractive, has to be beautiful. Some of you may have seen my TED talk in which I sort of stress that point. And so for me, elegance, delight, this is the thing that we make a difference. This is what we're judged on, ladies and gentlemen. The things we leave behind us, the legacy of structures we leave behind us, the public will judge us on whether they like it or not on whether it was affordable or whether it was complying with the Eurocode. So let's just remember that. And so, you know, elegant bridges, they're supremely elegant, Storbelt, Great Belt Eastern Bridge, just fantastic piece of work. And so these are just some of the things that I would say we need to keep in mind. But nobody teaches this in most engineering classes. I don't know about you, but I certainly find it difficult to find engineering schools that are doing it really well. I try when I teach. So let me just take you back 25 years. In the UK, we had a number of Millennium Bridge competitions. This one, of course, the famous one in London, which got a reputation for things that it didn't really want to have. The wobbly bridge, as you know, and it spawned a whole raft of discussions about bridge dynamics, thankfully. But anyway, yes, I got a rather interesting phone call from the chairman of Arup on the day they had to close it because it was wobbling, and saying, help, we need to sort out what was going wrong, which was a very interesting 18 months of work to fix it. Also, probably equally famous, the Gateshead Millennium Bridge, the opening blinking eye, as it's called, by Gifford, as they were then, now Ramble and Wilkins-Snare architects. And perhaps less well known, the York Millennium Bridge. That's just three of them. There were, I don't know, 25 or something built within a few years. And it was all triggered by this. I'm taking you back to 1992. The Bridge Design Seminar at the Royal Fine Arts Commission in the UK, which was also itself triggered by this man. Now, there was an exhibition in 1992 in London, the Royal Institute of British Architects, of his work, Santiago Calatrava's work. And there's no doubt, I think we would all agree, that Santiago created a kind of moment in history where we all opened our eyes to sort of new possibilities. I remember when I first came across his work, I thought, wow, this is bridge design with a difference, you know? And what happened was that, and this was the context at the time, these were bridges all sort of around or in process at the time. You'll know most of them, I'm sure. And what happened was that there was this argument going on in the UK over the East London River crossing. The top bridge being the design from the Department of Transport, Hal Crowe had been the designer, and the bottom bridge being an alternative proposed by Calatrava. It never happened, the bridge never happened, but the point is that it triggered this debate, this seminar, at which, incidentally, Fritz Leonhardt was there, Christian Menn was there, Santiago Calatrava was there, and all the kind of UK bridge designers, including myself for some reason. And it was extraordinary, actually, to be sitting there together with these people, because the UK had got terrible bridge design going on. Nobody was giving the first thought to what bridges looked like. It was simply engineers building basic bridges. You know, there was no imagination going on, very little thought given to elegance and delight and all that sort of stuff. And it was this had become a public debate. This had become a public issue, not just a profession issue. And so the debate in this seminar focused very quickly on the problem of commissioning bridge design, because the way in which design was commissioned was basically on the lowest fee. Because fee competition became a thing, mainly when Maggie Thatcher came along. And among the conclusions was obviously, no surprises, good design requires a good designer. So how do you find a good designer? Well, the first thing you don't do is go for the lowest fee. And so the other thing was giving the designer a proper role in the process. And this idea of a single overseeing mind, this idea that there is a designer, an individual, or a very small team. Because again, what had happened was that, and it's still happening, sadly, is that design was being done almost like by committee, you know, large groups of people. And that the designer should be retained throughout, preferably overseeing construction. Does that still happen? And there was a big push for competitions. And very quickly there was the Poole Harbour Bridge competition, 1994, which was really, okay, we happened to win it, but it was much more about raising the bar of expectation about what could be done with bridge design. And so little by little, we then had a whole raft of, that's the pool competition, which was a quite unique kind of location because this is relatively shallow water, only small boats use this space, so you could do a bridge which didn't have to worry about heavy vessels bumping into the supports or any of that sort of thing. And as this one unfortunately never got built for political reasons. The government changed, the Labour government came in and changed everything, cancelled just about every project in the country. But the first one of mine that did get built, the first Millennium Bridge, was this little aluminium footbridge in Maidstone, which is in Kent, southeast of England, working with Wilkinson-Eyre architects. And this is an aluminium bridge deck formed from aluminium extrusions. So it's an aluminium bridge deck formed from a series of sort of epsilon-shaped extrusions, back to back. And it's on a curve, so it's like a laminated beam. Super lightweight, actually quite cheap, but it was one of the lowest cost per square meter of all the Millennium Bridges. There it is. Thank you so much. So the pointer is that thing. Okay, good. Thank you so much. So there's the epsilon shape. That was the biggest extrusion we could make. In fact, it was a Belgian extruder, I think, because of the size, maximum size of the die, and it produced these things. And so you have a sort of cellular structure. And there's nothing else to add. One of the reasons why this is very cheap is because that is the structure. There's no secondary structure. It's just that's it. And then we had carbon fiber posts, parapet posts. It's all stressed together sideways. I like to think that it's probably reasonably sustainable in that everything can be reused. Although aluminium doesn't qualify very well on the carbon agenda. And then there are a number of other little bridges, strange little one I did here with Studio Bednarski, Cezary Bednarski, some of you will know him. And this one, which you've seen pictures of already. So this was also with Wilkinson-Eyre Architects. It's obviously a torsion box with cable stays on one side. The curved plan form means that it's possible to, by kind of adjusting the angle of the mast and the position of the mast, make sure that all the permanent loads are axial in the mast, so there's no... Some of the stays are pulling it forwards, some of the stays are pulling it backwards. So at the bottom, it's just axial forces. I'm surprised how many engineers, student engineers at least, but even quite well-qualified engineers still ask me, how does it work? Many of you here are quite happy to do a curved bridge being supported on one edge because, of course, it works. You know, you've got torsional stiffness. It's not a problem. But I don't know why people don't understand it, but it's pretty straightforward. It has, in this case, it has a thrust bearing at the center, just pulling it back against the mast, and then a torsionally restrained ends. But of course, the trouble with this kind of design is that you have to have temporary support. Now, in this, because you can't build it by cantilever construction like you would a conventional cable-stayed bridge. So it has to have a temporary support. In this case, completely possible because it was shallow water, very easy access, not much navigation problem. But from a low carbon and sustainability point of view, if we try to keep the carbon down, this would not score highly. So if I ask myself the question, how would I do things differently now, I think it would be a different design. It is interesting, what the client asked us for, they came along with a picture of the Gateshead Millennium Bridge, the blinking eye, and said, I want one of these. So I said, okay, and I wasn't sure why they needed it to open. I said, what's your budget? And he said, £3 million. I said, no, you can't have it. So realism has to kick in, and this was what they got. In fact, they got 2 bridges for £3 million, but I won't go into that. Then this is Halgevor, another one which was done around the same time. This is the first GRP, glass fiber reinforced plastic. The main part of the deck is glass fiber. The first one publicly funded in the UK. And the beautiful thing about it was how light it all is. All the flat panels, very easily built, little C-shaped edge beams. And all went in very, very simply, if I can get the pointer to work and press the right button. So you can see, with a little bit of temporary works on here, a little strut at each end, the cable acts to work during the lift. And then once you've got it in place, you just hook out the cable, attach it to the mast and lower away. And if you've got your sums right, it fits. And then the other little one, just to mention, is the Bridge of Aspiration in Covent Garden, which was mentioned in the introduction, between the Opera House and the Ballet School. The shortest bridge I've ever designed, rather fun. Another aluminium beam, actually. I've done it again. Oh, no, that's that one. Put that thing down. I think probably the most joy I've had out of any bridge to design, just because it's such fun. The idea of this, incidentally, was that the architect, the idea was to create a sense of movement. The brief was, from the ballet school, create a sense of movement and constrain the views from the people on the bridge down along the street, because the ballet school director had an apartment just to one side, and they didn't want people looking into his bedroom. So Jim Eyre, the architect, said, what if we take a square section, like a picture frame, and have several of them, and we twist them incrementally through 90 degrees. The problem is, and that's what we did, and it works. And this is the views, if you would stand on the bridge, are indeed constrained along the road. The problem is that the bridge doesn't just go straight across. It goes on an incline, and it goes on a skew. And this was the days when geometry had to be worked out by hand, and it was challenging. Anyway, there we go. And of course, Stonecutters Bridge, you know about. We won that competition and then lost it again. But of course, the trouble about competitions is that they also rely on having a jury that is competent enough to recognize something which is buildable and something which is not. And it sometimes goes wrong. So this was Glasgow. I won't mention who the designers were, but a bridge that I think the client ended up, this was awarded as the winner of this particular competition, and clearly was never going to work. And I think, I don't remember how many millions were spent trying to make it work before they abandoned the project. The same thing happened here. Perhaps difficult for you to see, but this sort of image, which was this sort of beautiful image which won the competition, these very, very slender masts have got stays on one side only. All right? And that one stays on the other side only. And of course, the engineers among you will immediately know that that is a complete impossibility. But nevertheless, it won the competition. And again, they forced the process where the client appointed the designer, and they tried and they tried and they tried and they tried to make it work. And of course, it was never going to work. And then this one in Poland, in Krakow. I remember Chris Wise seeing, you may know Chris Wise from Useful Simple, the engineering and expedition engineering, took one look at this photograph and said, oh, good heavens. This would work fine in zero gravity. Anyway, so what we now need to do is focus on carbon. You've all seen these sort of pictures before where carbon is going through the roof, and we're never going to make it down to zero in 2050, we know that. You know, the question is, what are we going to do? What are we doing? And we know that whatever number it is, 37%, 40%, whatever it is our fault. But we're also in control of the solution. This document, past 2080, is a thing which we use now pretty well universally in the UK. Carbon management in buildings and infrastructure. I recommend it to you if you haven't got, if you're not using it, or if you've probably got something similar. You know, we've all seen these kinds of pictures before. Build nothing, build less, build clever, etc. And so we need to move quickly. The Net Zero Bridges Group in the UK is also another panel worth looking at, because they are really looking at options and how do we really change the situation about how we do things. And the resources from the Institution of Structural Engineers I could also recommend to you, which include this tool, for example, of how you calculate carbon. You've probably all got your own. And we do it on every single project. This is from a slide borrowed from COE. Where they look at the sort of the average that they have had, sitting here at about D. This is a kind of 2,000 kilograms per square meter on your bridge structure. This is a 2030 target, and of course by 2050 we've got to get down here somewhere. And so, you know, this is a typical bridge that one of the ones that COE did recently with Moxon Architects, which is up there. For less than 500, you're doing pretty well. And these are the targets that we all need to be aiming for. And so, clearly, we need to think carefully about what we're doing. We must ask ourselves, do we really need to be building this stuff? Ask our client, what we're doing. And I'm going to go more quickly here because obviously I got something I wanted to say. One of the things we need to recognize is that we're constantly over-designing. This is from the Golden Gate Bridge anniversary. That's a big crowd, and it's 2.87, somebody worked out, kilonewtons per square meter. Well, we're designing for 5, sometimes 4, and then we put a big factor on it. So, we're over-designing. I love this picture. I'm just interested to know who the figure is in white. What was he doing? Anyway, I'm going to pass on for that one. Reusing steel in bridges is another thing which we should be doing more of. Repurposing the steel. This is a ghastly design, but it does illustrate the principle of just using repurposed steel tubes. In the UK, Cleveland Steel has a huge warehouse full of tubes available, waiting to be used. This is a project in Paris, which some of you know about, repurposing an old obsolete swing bridge as a footbridge as part of the Olympics. This has got to be the kind of way we want to use to make the best of the old materials we've got. I haven't got time to show it to you now, but do look this up if you haven't come across it yet. The bridge bank in Holland. You can just get hold of a bridge which is available. It's old, used, available. Let's reuse it. If you haven't looked at it, I recommend looking at this website. Just Google Dutch Bridge Bank and you'll find it. Did you know that the amount of man-made stuff on this planet is more than all global biomass put together? I mean, I'd only learnt that very recently. And it's astonishing. The amount of stuff that we make and use and waste is more than all the trees and plants and fungi and everything else on the planet. And that, I think, terrifies me. I'm going to click through this because it's actually not the point I wanted to make. So this is about a low-carbon footbridge, which we ran in the UK. There's a slide at the end I just want to show you, which is the figures. So this was a footbridge about 70 meters long, and this was the carbon at the end of phase 1 of the competition, so not quite the fully developed. But you can see that the lowest ones are right down here at about 100 kg per square meter. That's seriously low. And anything down that level is pretty impressive. Just something on the old structures. I started my life on this one, which was looking after an old bridge, a very famous, it's not very old bridge, but 1960s built, with the strengthening and changing the cable system on the wire bridge. But it emphasized for me the importance of keeping old structures alive. This was done entirely with traffic running on the bridge. And I'm nowadays looking after, have been looking after when I was with COE, structures like these, which are in desperate need of support and help and new leases of life. I'm going to finish with one slide because you're hovering in the corner, and I know that this is happening. We are talking a lot about getting to net zero, but that's not good enough, is it? And so we have to talk about regeneration. I borrowed this slide from Chris Wise, so I don't take any credit for it. But basically, we have this situation where we are, even now, degenerative. Okay, we're heading down a catastrophe slope. Now, we can curve it back. We're working on it. We can get back to some kind of a zero position, but we've got to start rebuilding. We've got to build into a regenerative situation. And this goes way beyond structure. This goes into the whole environment around what we build. And if only I had time to talk you through this checklist which he's got, I could highly recommend it to you, where you kind of catalogue things like, carbon-intensive materials, are they good or bad, fossil fuel for heating and cooling, all these sorts of things. And you grade it to get to a figure at the end to tell you whether your project is regenerative or degenerative. If anybody's interested, please come and see me afterwards, because I'm sure that Chris, who is the author of this, would be very happy to talk to you about it. So build nothing, if possible, but for goodness sake, please think hard about carbon and all the rest of it, and please make it beautiful. Thank you.
Thank you. Thank you so much. Ian Firth, also a lot of food for thought. Questions, comments? None.
You all want a cup of tea?
Hello, it's wonderful that you just raised up the theme about maintenance and everything in bridge. I think this is just I'm commenting basically. I can also ask questions, but maybe later. But I see the sustainability, like you presented here, in like a bigger vision where we not only build the bridge and leave it, but we take care of it because it's our creation, and it kind of supports our vision for the next generation, in the future. So I really love your message that take care for your bridges, This is what we want to leave for the next generation. Thank you.
Well, thank you for the comments. You're absolutely right. And actually, I spent more of my life in looking after existing bridges than I have on building new ones, designing new ones. It's absolutely essential that we understand that. And very often, we need to have a completely different mindset. With design, it's okay to use the codes because that's what they're there for. They're oversafe. They're ridiculously oversafe. We far over-design our structures. But with existing structures, nearly always, I find that some other consultant has condemned it. There's so many of our jobs we got that way. The client then comes to us and says, come on, you guys, you can think a bit more hardly, sharpen your pencils a bit and go outside the code, because you have to go back to first principles to understand. The bridge has been standing there for 50 years, so there's got to be something okay about it. So let's think a bit harder about how we look after those old bridges. I showed you the Severn Bridge and the old wonderful Freeman Fox 1965 suspension bridge. That when we were doing the strengthening of that, the consultant, who shall remain nameless, who went to the Houses of Parliament through his member of Parliament, who made a statement in front of the world on the thing that bridge should be knocked down and replaced.
I think one
Luckily, we were able to persuade them otherwise.
I think one problem that we have, especially in Germany, probably in Britain the same, is that financing of public projects prefers new projects. We don't get as much money to refurbish old projects, especially infrastructure. That's a big problem, even more than the structural mindset.
Who's from the United States? I mean, it's a serious problem. Because, the number of bridges in the United States that are desperately in need of serious money for maintenance. And sadly, unfortunately, it'll be another collapse that'll happen before more money is available. That's just the way of life. But no, we need it to happen.
Okay.
Are we done?
Okay, thank you.